Hello, everyone. Welcome. Thanks for taking time out to join us for this session on securing the software supply chain with AWS and SUSE. I am Ted Jones, which means you can say you attended a TED Talk at re:Invent. Congratulations. I've been in the industry for a little over 25 years. Joined SUSE in May of this year. I'm working with the global cloud team around architecture for the secure container platform domain. So security is near and dear to me. Spent 21 years at Red Hat before that, and I've been involved in application development and engineering. So I want to sort of frame the solution before I dive right into it. I'll talk about, kind of define the problem we're trying to solve, talk about what are the consequences of not securing your software supply chain, as well as define what the components of the software supply chain are, and then we'll look at how it could be attacked, and then get into the solution itself, and then we'll talk about next steps and call to action. So some of the issues that you can get with an attack, projects can be delayed while your teams are focused on fixing what was broken, and that could lead to product releases slipping, which could lead to more issues like compliance. Revenue can be impacted directly with downtime, and then you could also lose customers due to the loss of trust and then the downtime itself. And we like to point fingers, right? So we need someone to blame, and someone's going to probably lose their job because of these costs. Could be CISO level, C-suite, could be an architect or even frontline. Either way, you have to replace that talent. That's a lot of knowledge and experience that you've lost. So that's additional expenses that you're going to encounter. And then we also like to assign a dollar amount to it so we can understand exactly what the costs are. IBM comes out with a report every year, and they estimate around $5 billion or $5 million per incident, and that's subject to change, so your mileage might vary. You have to also consider fines and legal expenses on top of that. So that cost can go even higher. And then with ransomware, sky's the limit. So the components of the software supply chain for containers, you have a developer committing code, pushing it either a PR, pull request, or a commit to their source control library. They're using third-party tools like an IDE, integrated development environment. They also might have AI code assistance, so there's lots of other variables that are part of the software supply chain. Once they commit this code, it goes into the CI/CD process. We'll check to see if make sure we're not breaking other people's code with our changes, and then we'll push it into our image repository, kicks off the CD pipeline, and then gets deployed to the target environment. So where are the points of attack, vulnerabilities? Of course, code starts with code. It's proprietary, open source, and then our internal code bases that are leveraging third-party open source libraries that may or may not have CVEs, known vulnerabilities, or even zero-day vulnerabilities. And it could be a bad actor or a well-intentioned developer that has no idea that they're actually introducing these CVEs into the environment. So it's people, good and bad. Processes can be hijacked. The signing process of packages could be hijacked. There could be a malware attack, phishing attempts. There's lots of ways for bad actors to get vulnerabilities into your environment. And then application misconfiguration can lead to issues as well. Like you could use a port that would expose vulnerabilities within your environment. You could use a namespace that it should be protected but is being used by a developer as part of their container push. And then we've got the same issues with infrastructure misconfiguration, where they could be using bad ports, they could be allowing root access to containers. So we need ways to circumvent that. So there's a couple of models that have been used for security. First one being the CIA triad. It started back in the 80s. It was introduced by NIST, and it's held up for about 40 years. CIA is not the Central Intelligence Agency. It's a confidentiality, integrity, and availability. So confidentiality in that we're protecting the data and the full life cycle of the data. And then integrity is we're guaranteeing that it's not being altered anywhere along the life cycle. And then availability, of course, is making sure that our operating systems and systems, our applications, are safeguarded against downtime. So, like I said, it's held up for 40 years, but with the infrastructure changes and the way that we develop applications and run them, we had to kind of modify that. So in 2019, Sunil Yu, co-founder at Gnostic, came out with the DIE triad. So this is more around distributed systems. So you don't want a single point of failure. So you have to have that data kind of spread out. And then with, my slides aren't moving, sorry. Then immutable, meaning that once that data is written, it can't be changed. And then finally, ephemeral is that data will have a short and well-defined lifespan. And this really is in response to containers, Kubernetes, and cloud environments. And it's also a move away from the pets versus cattle analogy, if you're familiar with that. So pets, we name our pets. If they get sick, we take them to the vet, we feed and water them. And that really worked well back in the 80s with legacy data systems. But with cattle, they're more, which is actually how Rancher got its name, the cattle analogy, where if you lose one server, you just replace it with another. So they're tagged sort of like cattle in a herd. And it leads to better resiliency and security. But there's a lot of CIA models out there still today because of legacy data systems. So you want to start with a SUSE Rancher Prime, which is built using SALSA Level 3 compliance. And SALSA is delicious, but it's also a model for ensuring that code is built in a way that can be attested to. So we know where all the sources came from. You have an SBOM, a software bill of materials for each build. It also allows you to create users for all of your Kubernetes clusters. It allows you to import from like LDAP and Active Directory and other sources. So there's a lot of security built into Rancher Prime out of the box. I'm missing. Oh, sorry. Also, our application collection. This is one of the best kept secrets, I think, at SUSE. What we do, we take open source libraries and build a curated deployment of that. So if there's any known CVEs in the upstream projects, we will patch those for you. And this is fully supported by SUSE and allows you to run enterprise-grade applications like Argo CD or Istio. And then we work with partners to support their Helm charts with the exact same support model and peace of mind from a security standpoint. And I already gave observability away. So we acquired a company called StackState earlier this year, and this became our SUSE observability product. Observability and security have really kind of meshed. So it used to be observability was more about just problem remediation, and now it's more about keeping our system secure and compliant. So both Rancher Prime and SUSE Observability are available in the marketplace. We actually have a 6-month free trial going on with SUSE Cloud Observability. You can sign up for that. We've got a QR code over our booth, and that will enter you into a raffle for a MetaQuest 3 set of goggles. And you can also just check out the demo we have going over there as well to get in that raffle. And then KubeWarden is a admission controller and policy engine. It's sort of the last gate of images as they go into your environment. There's hundreds of predefined policies that you can use as part of that. If you want to write your own custom policies, we have, the community has several SDKs available for that. And then that can be tied directly into your AWS code pipeline. So if you want to assure that certain ports are not being used, namespaces, or making sure that Kubernetes or containers aren't being allowed root access, that sort of thing, you can plug that in. And then SUSE Security is sort of an extension of KubeWarden. You can also do admission control with that. But it also has compliance scanning that could be plugged into your CI/CD pipeline, CVE scanning constantly. And then also, by default, it goes into something called Discover mode, which will kind of learn how your applications act and will automatically create policies in your environment, which you can either accept or decline or even edit. You can add your own custom policies as well, all through the UI. And then in test and in production, so in test you'd probably would want to test out those learned policies, so you would run that in monitor mode, so you would just get alerts. If something outside of those predefined policies happened, you would be alerted by that. In production, you would use protect typically, so protect is like behavior zero trust. There's based on this behavior, I do not trust what this person is trying to do because it's outside of the policy. And that could be set at very fine grain, with different applications. It's not all production. It could be set at the application level. And then we also include our SUSE private container image repository as part of Rancher Prime. So if you want a trusted repository managed and hosted by SUSE, constantly scanned for CVEs, and protected, it's based on the Harbor community project. That's available to you as well. You don't have to use it, but it's there. So we are completely open source at SUSE, and so every product that we have is based on open source projects. We just went through a rebranding at KubeCon, so we announced that a few weeks ago. SUSE Security, which I talked about, is a combination of New Vector and KubeWarden. SUSE Observability is State Stack, and again, that is available as a SaaS offering in AWS. Free for 6 months, no obligation. SUSE Rancher Prime, it's a combination of the application collection, we call it AppCo for short, a secure build of Rancher Community, SUSE Security, and SUSE Observability altogether. SUSE Virtualization, so if you want to run virtual machines in a container environment side by side with containers, Harvester is the project for that. It's based on KubeVirt. It's really gaining a lot of traction with some of the shakeup that's going on with VMware. And then Longhorn is our storage solution that plugs right into both SUSE Virtualization and also any Kubernetes distribution. And then if you want all of the above, we have a product called SUSE Rancher Suite, so that gives you everything all in one SKU. We do have a landing page on our SUSE.com website for AWS, so you can check that out here. I also wrote a blog, which is listed here, so feel free to check that out, bookmark it. Would love any feedback that you have around that. And then, of course, I'm obligated to ask you to fill out the survey, if you don't mind. It's helpful. And come on, see us over at the booth. We're at 1858, I believe. We've got a fun game to play where you can win prizes. And then also see some demos, check out SUSE Observability. We've got SUSE Rancher running. We also have a SUSE security demo as well. We'd love to get your feedback and answer any questions you have. Thank you.